Welcome students to the last video of this chapter. This video will cover exercises 3.6 and 3.7 of your chapter playing with numbers. In this video we will learn about highest common factor, that is HCF, lowest common multiple LCM, and some real life explanation with examples of their application. So let's start off. First we have highest common factor. As the name suggests, it's pretty simple. Highest common factor of two or more numbers is the highest or the greatest of their common factors. Obviously. So to find the HCF or two or more numbers, we find the prime factorization of all the numbers, because what prime factorization gives is all the prime factors of the given number, and then pick the common prime factors of all the number and then multiply them. The product of the product is the HCF of given numbers. Let me explain this with an example. For example, let's say we have 20 and 32. We have to find the HCF of these numbers, 20 and 32. So prime factorization of 20 is we prime factorize 20 and we have 2 into 2 into 5. And prime factorization of 32 is 2 into 2 into 2 into 2 into 2, 5 times 2. So the common factor of 20 and 32 is like we have 2 here 2 times and we have 2 here common, like we have 2 here 2 times and we have 2 here 4 times, but what we have in common is 2 times 2. Okay, like we have 5 here but we don't have 5 here. We have 3 extra 2's but we don't have 3 extra 2's here. What is common is these 2's. So common factor of 20 and 32 is 2 times 2, where 2 into 2 is equal to 4. Let me explain with another example. It will make much clearer, the concept much clearer. Let's say we have 48, 64 and 120. We have three numbers and we have to find common factor of these three numbers. So the prime factorization of 48 is 2 into 2 into 2 into 2 into 3. Prime factorization of 64 is 2 into 2 into 2 into 2 into 2 into 2. And prime factorization of 120 is 2 into 2 into 2 into 3 into 5. So what we have common in 48 and 64, let's say what we have common here. So we have 4 2's and 1 3, and we have 6 2's. So we have 4 2's common in both of them. 3 is not present here and we have 2 extra 2's. So 4 2's are common in both of them. So we have 4 2's here. And what is common in 120 and both of the 48 and 64? So we had 4 2's from there. Now we have 3 2's, 1 3 and 5. So what is common to all of them is 3 2's, because we had 4 2's from here and here we have only 3 2's. So what is common in all of the three numbers is 3 times 2. Like 3 times 2 is coming in all of the numbers, like 2 into 2 into 2, 2 into 2 into 2. The remaining portion is not common to all of them. Okay. So the HCF of all these three numbers would be 3 times 2, that is 2 into 2 into 2, 8. Okay, I think you will be clear with the concept of HCF. Now let's move on to the next concept, that is lowest common multiple. As the name suggests, lowest common multiple of two or more given numbers is the lowest possible common multiple of the numbers, obviously. So if we have two numbers, then the lowest common multiple will be the lowest possible common multiple of the two numbers. How we find the LCM? We have a method to find the LCM and it is very easy. I'll show you with an example. Let's say we have 16, 15 and 12 and we have to find the LCM of 16, 15 and 12. So we write all the numbers in separate rows, like first row, second row, third row, 16, 15 and 12. Okay, and then start a process similar to prime factorization. You see we have a table drawn here which is similar to prime factorization table. Except here, if a number is not divisible by a given prime number, we carry it to next step. So let's say we start with 2, like we start with the smallest number in prime factorization, we start with 2. So 2 8s are 16, we have 8, 2 6 are 12, we have 6, but 15 is not divisible by 2, so we carry 15 itself, like no change, without changing 15 we carry it to the next level. And now we have 8, 15 and 6 in this new column. Okay, so if number is not divisible by a given prime number, we carry it without changing to the next level. So we repeat the step. We again see if 2 divides any of these numbers. So 2 again divides 2 4s are 8, 2 3s are 6, and 15 is left. So we carry it to the next level. Then again 2 2s are 4. Now 15 is not divisible and neither is 3. So we carry both of them to the next level without changing. Now we have 2, 15 and 3. Now 2 and 3 both are prime numbers. So our main motive here is to reach prime numbers. The end results should all be prime numbers, like these, and the bottom ones should all be prime numbers, like prime factorization. Okay, so 2 and 3 are both prime numbers.